students, and welcome back to part 2 of our acids and bases notes here for the week. There won't be many notes here today, as I mentioned yesterday, because we're going to transition to our classroom activity after these brief notes. So I would like you to open up your books to where we did leave off yesterday, and we're going to finish this up rather quickly, but there are some things I want to focus on which will help us out. Yesterday, if you recall, we ended with the pH scale. And the pH scale is a range of numbers from 0 to 14. And the lower the number, the more acidic. The higher the number, the more basic. And right in the middle is number 7, which is neutral. Neutral is right in the middle. Now, I'm emphasizing that word neutral because it ties into this next thing I want to discuss with you. No, not the virtual lab, rather a word called neutralization. We'll get to the lab soon enough. Neutralization is a reaction between an acid and a base that produces salt and water. Now, as you're writing that down, I want you to remember something that I've mentioned in the past. There are many different kinds of salts. When we think of salts, what immediately comes to mind is table salt, perhaps. But table salt, which we know as sodium chloride, is only one of dozens of different kinds of salts. So please keep that in mind because not every salt is sodium chloride. But it is in the example that I'm giving you here for a good reason, because you are familiar with it. So let's look at this chemical equation, shall we? I'm writing here HCl, hydrochloric acid or hydrogen chloride. And I want you to remember a couple things I mentioned to you yesterday. Remember how I said if you look at the chemical formula of something, if it begins with an H, chances are it's an acid. Well, hydrochloric acid is an acid. If we combine hydrochloric acid, sodium hydroxide, NaOH, again, do you remember what I said yesterday? If a formula ends with an OH, chances are that hydroxide is indicative of that substance being a base. So here we have an acid, here we have a base. And if you combine the two together, do you remember what they form in solution? Look up in your notes from yesterday. In solution, what does an acid produce? A positive hydrogen ion. A positive hydrogen ion. What do bases produce in solution? A negative hydroxide ion. And what happens when you put a positive and a negative together? True love. They go together. They go together. So remember also yesterday, I mentioned how they go together to form HOH. Think about that from yesterday. What's another way of writing HOH? You've got 2 hydrogen atoms and 1 oxygen atom. Do you see it written right above here? HOH is the same thing as H2O. Chemically, it's a little bit more accurate to write it HOH when we're dealing with acids and bases because water is something that is formed during a neutralization reaction of an acid and a base. And it's because of that positive hydrogen ion, that negative hydroxide ion coming together to form the HOH, which is otherwise known as water, H2O. But also notice what happens with the chlorine and the hydroxide. They also come together in order to form, in this case, sodium chloride. Sodium chloride we know as salt. But again, as I mentioned, there are many different kinds of salt. This is just the one most familiar to us. By the way, if you recall the different types of chemical reactions, you may also recognize that a neutralization reaction is a special type of a double replacement reaction. Notice the two metals, hydrogen and sodium, are replacing one another here in this particular reaction. But know that a neutralization reaction is one in which an acid and a base come together to produce salt and water. And if it's a perfect neutralization reaction, then the acid and the base will neutralize one another. So what do you think the pH will be if they are neutralized? It will be a pH of 7. Now, I mentioned a specific kind of neutralization where they are in perfect balance with one another. This also has a special name to it, and it's called titration. An acid-base titration reaction is a neutralization reaction used to determine the volume and the concentration of acids and bases. And typically, it's used in order to neutralize the acid and the base. Now, I'm going to show you let me show you this diagram first of all. If I show you this diagram, we've got different figures here, titration of an acid with a base, and you see a difference in color here. We're going to be doing this as part of our classroom activity when we're done with our notes here. So I'm going to show you in real life the neutralization or the titration dealing with that pink stuff, which if you remember from yesterday is phenolphthalein. So we're going to be using some phenolphthalein in just a little while. Here is the titration equation. Now, for those of you who love math and are doing well in math, you can probably see what's going on here pretty readily, and chances are in high school you're going to be using the titration equation readily. If you're not so keen on math, don't worry about this too much. Don't freak out. Don't panic. But I would like you to write it down nonetheless. I'll explain it to you. First, I'll read it to you, and it says N sub A times V sub A equals N sub B times V sub B. Well, what the heck does that really mean? Well, if you look at the little key, the guide down below, the little a is referring to the acid, the little b is referring to the base. The capital N is a word called normality. I don't know anything about that. No, normality is something that I don't possess. But normality is a measure of the concentration of either an acid or a base. It's a measure of concentration. Just know that for now. V is a measure of volume, and we'll be measuring volume in terms of milliliters. So N is normality, a measure of concentration. V, a measure of volume in milliliters. So look at the equation here. Basically what you have is this. The concentration times the volume of an acid is always equal to the concentration times the volume of a base in a titration neutralization reaction. In other words, If you are able to neutralize an acid and a base to get a pH of 7, then I should say, if you can get a pH of 7 in a neutralization reaction, then you can always multiply the concentration times the volume of the acid and equal the concentration times the volume of the base. Now, this is just a really cool mathematical reality that exists in chemistry, but there is a practical application that I can think of. Let's say later in life you want to be on a hazmat team, a hazardous material team, and let's say you're working for the county and you're a member of the hazmat team, and there's a truck riding down the highway filled with, oh, I don't know, a strong acid or a strong base. And there's a traffic accident and it spills a certain known volume and a known concentration of an acid or a base all over the roadway. And you are called in to help clean up the mess. Well, you're going to have to know this titration equation because you're going to have to calculate the concentration and the volume of either the acid or the base, the opposite thing that spilled, in order to neutralize that road spill before it gets into the water stream. That would be bad. It's a lot safer to have just salt water enter a water stream than a strong acid or a strong base, which is going to kill all of the living things in that water body. So it's up to you, hazmat team, to be able to take this titration equation and put it into practice and save the environment and maybe save your life too, because maybe there's a public water supply downstream from this spill. Golly, who knew that science could save your life like this in a pinch? So there's just one quick example I can think of a practical application of the titration equation. So not only is it pretty cool, it also can be pretty important. All right, now for us to finish up here today, I would like to review with you all of the information that we've gone over yesterday and today, namely the different tests that can be used, because at the end of this video, we're going to do the classroom activity together, and you're going to have to make some observations, and I'm not going to tell you the answer. You're going to have to use your notes here based on this summary to give you the answers. Likewise with our lab activity tomorrow. So let's do a quick review. Red litmus paper. If you have red litmus paper and you touch it to an acid or a base, this is the result. Red litmus paper will retain its red color in the presence of a base, but red litmus paper will turn blue in the presence of a base. Did I just say that wrong? Let me repeat myself. Red litmus paper will remain red in the presence of an acid and will turn blue in the presence of a base. We'll see that with our activity in just a few moments. Next, blue litmus paper. Blue litmus paper will turn blue. I'm a little bit tired right now. Blue litmus paper will turn red in the presence of an acid and will remain blue in the presence of a base. The bottom line is this with both red and blue litmus paper. The bottom line is bases are blue. So red litmus paper will turn blue, blue litmus paper will stay blue in the presence of a base. Base is blue. Maybe that'll help you remember which one is which. And the opposite is also true, that red is the color with an acid. Maybe you can think of acids and your stomach on fire and your face turning red. Red litmus paper, blue litmus paper, the end color is red with an acid. All right, next we've got the phenolphthalein. Say it one more time, can you? Phenolphthalein. Okay. Phenolphthalein will remain clear in the presence of an acid and will turn pink in the presence of a base. And finally, the pH paper. pH paper. The pH paper will turn a certain color, and you have to match up that color with the guide. And if the value of that color is less than 7, it's a base. And the lower the number, an acid. And the lower the number, the stronger the acid. And if it's higher than a 7, it is a base. And the higher the number, the stronger the base. So pH paper, small number acid, big number base. Big number base. It's all about that base, No trouble. It's all about that base. The bigger the number, the bigger the base. You get the idea. Okay. So those are our notes. And now we're going to use the remainder of our time to get into our activity. First, our classroom activity, and then tomorrow, our lab activity. So, enough of my misspeaking here today. I need to take a little break and a little breather so that next time I speak, I'll be completely 100% accurate. But these are the correct notes for you in your book. So until we see you again in just a moment with the classroom activity, bye-bye.